Mendeleev arranged the elements known at that time in a chart in a systematic order in the increasing order of their atomic weights. He divided the chart into 8 vertical columns known as groups. Each group is divided into A, B subgroups. Each column contained elements of similar chemical properties. The elements in the first column, for example, react with oxygen to form compounds with the general formula R2O. For example, Li, Na and K when react with oxygen and form compounds Li2O, Na2O and K2O respectively. Elements of the second column react with oxygen to form compounds with the general formula RO. For example, Pe, Mg and Ca when react with oxygen form BeO, MgO and CaO. Mendeleev tried to explain the similarities of elements in the same group in terms of their common valency. The periodic law. Based on Mendeleev's observations regarding to properties of elements in the periodic table, a law known as the periodic law of the properties of elements was proposed as follows. The law states that the physical and chemical properties of the elements are a periodic function of their atomic weights. Mendeleev's periodic table of 1871 version. Silent features. Groups and subgroups. There are 8 vertical columns called groups represented by Roman numerals 1 to 8. Each group is divided into 2 subgroups A and B. The elements represent in a group and its subgroups have similar properties. For example, subgroup Ia elements called alkali metals, that is Li, Na, K, Rb, Cs and Fr, periods. The horizontal row in Mendeleev's table are called periods. There are 7 periods denoted by Arab numerals 1 to 7. A period comprises the entire range of elements after which properties repeat themselves. Predicting the properties of missing elements. Based on the arrangement of the elements in the table, he predicted that some elements were missing and left backspace at the appropriate places in the table. He named those elements tentatively by adding the prefix eka, that means 1, to the name of the element immediately above the each empty space. Example, eka boron, eka aluminium and eka silicon were close to the observed properties of scandium, gallium and germanium respectively, which were discovered later. Correction of atomic mass. The correct placement of elements in Mendeleev's periodic table helped in correcting the atom masses of some elements like beryllium, indium, gold. Anomalous series. Some anomalous, that is, irregular series of elements like De and I were observed in the table. The anomalous series contained elements with more atomic weight like Te placed before the element with less atomic weight like I. Do you know Mendeleev said about the melting point of Ega, Ai, as if I hold it in my hand. It will melt. The melting point of Ga is 30.2 degrees Celsius and our body temperature is 37 degrees Celsius. Limitations of Mendeleev's periodic table. Anomalous pair of elements. Certain elements of highest atomic weights predict those with lower atomic weights. Example: tellurium, atomic weight 127.6, Praseodymium iodine, atomic weight 126.0. Dissimilar elements placed together. Elements with dissimilar properties were placed in same groups as subgroup B. Example: alkali metals like Li, Na, K, etc. of Ia group have little resemblance with image metal like Cu, Ag, and Au of Ib group. Cl is of 7A group and Mn is of 7B, but chlorine is a non-metal where Mn is a metal. Do you know? At the time when Mendeleev introduced his periodic table, even electrons were not discovered. Even then, the periodic table was able to provide a scientific base for the study of chemistry of elements. In his honor, the 101th element was named Mendeleevium.